Right, folks, so we've talked about IP version 4 addressing and splitting of subnets. The next thing is IP version 6 has different approach to the whole thing of splitting networks. And the materials is more about this, okay, and it's worth understanding this, okay, because this has come up before in skills tests as a section, which has got people a little bit confused. So I really would emphasize to learn subnetting of IP version 6. It is the future as well. There's more of this that needs to happen. So the general address, okay, the IP version 6 address consists of a /48 global routing prefix, a 16-bit subnet ID, and a 64-bit interface ID. They've already split it up to plan this in advance. Okay, there's never an issue about number of spaces of IP version 6, as you know. So therefore, that's not the reason why there's no issue of limitation. It's more about having logical schemes, okay, to address the network. Something that's really easy to understand. And logical means not physical. I mean, normally you go about addressing in a physical way, IP version 4. Cables are involved, Ethernet connections are involved, and you do things based on the addressing systems like that to make it simple, but this is a different approach. So this subnet ID is 16 bits in a subnet ID. Okay, how many addresses might that be? Bring up our calculator, binary. Okay, it's just ones. That's 16 there, right? Addresses available, 65,535. Okay, are available in 16 bits for subnets. That's how many subnets you can have. Okay, on that section anyway, as you can see here, 65,536. That's how many you can have in the subnets. So there's plenty available, and the host ID is vast as well. So address waste is not a concern in IP version 6, and we concentrate on designing a logical scheme to address the network. Yeah? So I'm just going to refer to the materials here in the gateway. Go to version 6. The section size of it, it's this big. Let's pull out some of these things here. And there's packet tracer activities also to go with this particular implementation. So the address itself, let's look at how this address is structured visually. So you've got global routing prefix, your subnet ID and interface ID. Click on those things to get more information about them. Let's flip forward. Subnetting using, here's some examples of how it's done. So if you're subnetting, if you're incrementing, if you're making a subnet, you simply enhance this number here by 1 to make another network. Okay, you increment it by 1 to create the different subnets. This goes all the way up to a higher number. Now, these 4 digits here, 000, the difference is with IP version 6 is it's not based on binary. It's based on another numbering system. Do you recognize what a numbering system is?
Hexadecimal?
Correct. And what is the range of hexadecimal? Mass?
Isn't it like altogether, you're talking about the IP?
Just a range. Like binary is 0 or 1, right? So what can hexadecimal be? What's the full range of it? It can be F, correct, right? So you guys familiar with hexadecimal as a numbering system? You may not be. Who's not familiar with it at all? Who's never heard of hexadecimal before? Anyone never heard of hex before? Folks, just say it. I mean, it's okay, right? Yes. Fine, thank you. you might not be the only one. Okay, look at this range here. Okay, it's a very different numbering system here. We've got here a different base number. Now, when I was at maths, look at this. Oh, look at all this. It's quite cool, isn't it? That's like a side track. Look at all this, eh? It's our decimal system there. Another. Which language is this? Yeah, look at that, numbers.
In the Chinese,
yeah.
It's just the same as numbers, maybe.
Roman numerals. What's that?
It's all numbers.
Which language is this? Is this Telugu or something? What is that? That's Chinese, right?
Yes. Japanese.
Yeah. Japanese, really? Oh, you know Japanese, don't you, Matt?
No, not really, but I know the letters look a bit more.
Numbers, that's 4. Look at this, 3, 4, 5, 6.
It's more like, yeah.
Is that Aztec? What is that? That looks familiar. That Thai. Is that Thai? Looks like Thai to me. That's Telugu. Oh, you recognize? You recognize it, Kamara? Which languages? They look very similar, these languages. These three are very similar. Look at the way they're written, some of the syllables are very similar. 4, 4. Interesting. It's a whole bit of an area of exploration, really. But anyway, on to the maths world. Hexadecimal is base 16, which means there's 16 values. Not only 0 to 9, but also A, B, C, D, E, and F. Suddenly you've got a much greater range. You don't got 0 and 1 anymore, you've got 0 to F. It's another like scaling up. So, how we can do this is, let's get back to my references here. We can just increment all the way up to F on the first digit, and then next time round, the 1 goes there, it goes 1, 0, 1, 1, 1, 2, 1, 3, up 1, 1, C, up to F. Sure, okay, further on. (64 subnets). It says it supports up to 18 quintillion host IPv6 addresses per subnet. Oh my word. Yeah, 18 quintillion. Okay, right. So, no conversion to binary required. To determine the next available subnet, just count up the hexadecimal. Just go up in values. That's what you got to do. So, example given here. Let's zoom this up and make it bigger text. Assume an organization has been assigned the 001-0DB8 a CAD/48 global routing prefix with a 16-bit subnet ID. Okay, that's the assignment there. This allows 64 subnets, as shown in the figure. The global routing prefix is the same for all subnets. This is the global routing prefix. All of this, yes, the same for all subnets. Only that value after this 0001, is incremented for each subnet. Okay, this bit stays the same. So really, this is about to allocate a subnet to these different addresses. All we're doing is we're simply, here's an example of some subnets here. How many networks do you think this could be, folks? Look at this carefully.
6.
Not 6.
It's not 6. It's
9.
It's 10.
I think it's 10. 4. Everyone's got a different answer.
It's not 6. It's probably 10.
Everyone's got a different answer.
9.
No. It's definitely 6. No.
Okay, you think it's 6? You think it's 9?
Okay, wait.
So what you're thinking is that all these lines are networks, right?
So there's like 1, 2, 3. A computer and a switch is one network.
Right? Potentially,
Six.
yeah, kind of.
And the
It could be 4, 6, yeah. 6, yeah.
You think it's 6? All right. In your packet tracer activity is a very similar question to this
6 for
in the lab, right?
it's 6.
Well, let's look what it says here, right? The example topology requires subnets for each local area network, as well as, this is each local area network here, right? These are all different networks here. One switch, one network, switch, switch, switch. There's 4 networks there, okay? As well as for the WAN link between R1 and R2. Okay?
6.
5 IPv6 subnets are used here. 1, 2, 3, 4, 5. Okay? The addressing here, .1 and .10 are on the same network. Yeah, they're not separate networks. To create the network itself, you have to address the interface on a router. Yeah? Even the switch has a virtual address. But they're all on the same network line, right? These are all together. Because you have to get to the router. It's just logic. It's a bit this just shows you visually how it makes sense, right? You've got to get to the router. So how are you going to get to the router? You've got to have a network address, right? You've got to get down the network to get down to it. This machine has got to be able to go down this line to .1, which is the default gateway, the router. So to get here, this is one network, this whole zone here. Here's another one, here's another one, and here's another one. So it makes sense? And this red line is a serial link. It needs its own network. Dot 1 and dot 2 are requiring a different network entirely. They're not off. They're not on this grid here. This machine should not be able to get to here, right? Shouldn't have access to that. But it can go via this router. If it's got permission, it then will go to R2 by the serial link, and same way backwards. Okay. Okay. So you've got this allocation of 5 subnets. Each /64 subnet gives more address than what needed. Okay, here's how the assignment works. Let's flick it forward by 2. So this shows you how the subnets are actually done. It's just visible at the back, guys. You read that. It's supposed to be hard to read this. Sorry. Just chunk it in. See that? 5 subnets allocated from 65,000 available subnets. Here's 5 subnets being allocated. Here's your address block. So I'm making 5 subnets this way. And then I'm going here. And I'm going like this. Oh, doesn't say much of this. It's showing me how the addressing is actually being applied. So can you see this? That's my network address, IPv6, that one there, and that one there. Okay. The dot ones are just like the actual host points. And your other network is over here. Just zoom to the right. There it is. You got another one over here. They made a mistake with this, haven't they?
Yeah, all 2.
They've got to 3, 4, and 5. That's a mistake they've made. This is the thing with Cisco materials. You can't always guarantee them. Right? And there's also how it's configured. Now, the configuration of a version, IPv6 network is done using these commands. So there'll be some practical activities and packet tracing you'll have to do. And I really recommend you look at this because this does likely to come up in your skills test. Okay. So interface, what you do is you go to R1, you configure it. You go to the gigabit Ethernet interface. You do IPv6 address, and you address it in that one. I haven't got zeros, by the way, trailing here. One reason why that's not needed is because you don't need to have any. You can remove zeros. They're just like, you can put them in, no problem, but they don't need to. You can just say 1. It just makes it easier. Yeah?
But if it's over 10?
Oh yeah, if it's over 10, then you would write 10. Because it's 0010, I can remove what are called the preceding zeros in a number. It's just efficiency. Or you can write it as 0001 or 0002 or 0010.
So there is no subnet mask here, or it's just the /64 itself?
Just /64 is a prefix, a standard prefix for IPv6. Subnet mask, confusion, complexity not needed. It's actually a lot easier. It's less sophisticated. All you remember is just the increments needed. And the way you name these, if you memorize how you name these things, if you are going to do it, that's why I recommend you do packet tracer. The second one I give you in the class is to do this particular configuration. Yeah? There you go, that one there, that one there, that one, this one there. There you go. There's 4 different things. Let's come back out of this. There's 3. Look at the serial one too, by the way, being done. Yeah? Also being done there. All right. Okay, now put that up over here. What's next here? Next one along. So this packet tracer is just to implement that subnetting scheme, and this is what it looks like, the actual document. You've got a network like that. Gives you an indicator for like what the addressing scheme is going to look like. Notice the front of it there. Yeah, and it asks you to, number 1 is address R1, G00 LAN, then the other one, and so on, and the WAN link. Okay, it's a little bit confusing, but I mean, by doing it, you'll get a lot out of this activity. So I want you to spend time on those packet trace things, okay, right now. I think it will help you cement your knowledge on this stuff. So what you should do is, the activities I highlighted earlier, I want you to do these packet tracers. Now, if you want any assistance on these things, I'm obviously around, but I'll help you nudge you along. Also, our friend Christian Romerio is on YouTube, so he'll have a supporting thing to go with this. Oh, I didn't highlight that one. What am I doing? In recommendation, I cannot, not. I don't know. We need to include this really. Needs to be there. There you go. Okay, that's the ones I'd recommend really here, these three. So, given these three are the ones to look at, any one of these you can do a search on YouTube for. You should get back our friend, YouTube, with a walkthrough that goes with it. I also have a solution sheet as well, which I will print out myself, keep with me. I'll get that in a minute. Where's our friend Christian? There he is there. 8314. His ones are pretty. I mean, there are other ones, but his are pretty good.
You need to get Grammarly.
I can kind of follow them.
All day, every day.
There's a new one that's doing it actually. Who's this new guy?
Hi friends, so welcome to all. In this video, we are going 6 Access 2001:DB8.
Yeah.
Well,
that's new, isn't it?
As seen,
that's
it's
quite
the
nice.
R1 LAN attached to the Gigabit Ethernet 0/0 as shown in the subnet table.
Not bad.
Here you can see that.
Well, maybe that's be alright as well. Doesn't look bad to me. It's quite clear actually. So give it a go. It's not TechAcad is doing it as well now. It's other new. People do often comment on these things. He's had a few thousand views on that. Not bad. Our friend Christian's had 27,000 views in his one. So you have loads of comments and stuff I expect on his. There he goes. Yeah, and then he does his bit as well. And he's this nice kind of methodical way. I would like you guys to do this one, right? So let me leave this up on the screen. Shall I put the YouTube link somewhere, or can you find them? Did you see how I searched for them, yeah? Yeah, I'll do it for you, no problem. Let me get the links onto WhatsApp then, okay? WhatsApp or where? WhatsApp okay?
YouTube.
Well, you know what? It's worth you knowing how to find these yourself, right? What I did was YouTube and just search 8.3.1.4 packet tracer. That's it. Just the activity and then the name, and I go back, see what comes up. I can TechAcad wasn't bad. Christian's always good. Gozetta. Yeah, try and search it yourself, folks. It's much better if you can do that.
The same as your Gmail as your phone. If you sign in, you can save them for other time.
Okay. Okay, good. Right, so we've got here 8114. Okay, find it? No, I'm going to help you find it. Just have it anytime. There you go, that's right. TechAcad isn't bad actually. That's what I want. Right, let's keep on the screen the ones you've got to do. And headphones are recommended, please, if you have them. I'll screenshot that and put it on WhatsApp. Let's pause it there.